Okay, good morning, everyone. Today we'll start with the topic of data warehousing and SQL basics. But before that, we'll just recap the previous class because we do have a lot of gap in between today's class and last class. So we'll just recap the evolution of the Snowflake. So coming to the evolution, like it started with the on-premises EDW, and it has evolved into the first generation cloud, and later Hadoop, data lake, big data, and now the cloud data platform, which is like we do have other flavors in market, but Snowflake. So any data warehouse or any enterprise data warehouse will be measured like if we should consider it as an ideal data warehouse. Majorly we need to have these four categories needs to be passed. One is all data in the sense all types of data needs to be processed by the data warehouse. Processed in the sense accept and give the data to the consumers. So this data needs to be accepted, processed by any data warehouse. So what does all types of data means? So we do have data in the form of structured, semi-structured, and unstructured. Structured in the sense like whatever the data available in the form of rows and columns. So if any data is available in the form of rows and columns, like which is nothing but a tabular format, then we will call it as a structured data. Semi-structured data means like it is in a readable format, but not in the form of rows and columns. It's like call key value and key and value combination. So that we can consider JSON files, XML files, paraquet files, ORC files, like that. So to convert the semi-structured data into the structured data, our data warehouse should process. And unstructured data, so unstructured data in the sense, see, it is not at all readable format. If it may be an image, so from the image we want to derive the information, so that type of files we will call it as a unstructured data set. So any data warehouse, if it process all types of this data information, then we will call it as a ideal data warehouse. And all users, so the elasticity, so when there is a heavy demand or heavy traffic is there, at that time it should accommodate the huge number of users. If there is no demand, no traffic, then it can just shrink to the lowest data warehouse and can accommodate less number of people. So the same thing, like if it can accommodate in any criteria, then we will consider that it as a ideal data warehouse. And fast answers, like whenever we want to retrieve some information, like if it is not buffering and getting the information instantly, then we will call that as a fast answers. So if any data warehouse is providing fast answers, then we can consider it as a ideal data warehouse. And SQL database, so suppose like whatever the evolutions seeing, like from 1970s, the data warehouses are following the language to design the data warehouse. We are using SQL database. So if that technology is holding SQL database, then it will be very efficient. Whoever knew the SQL technology also, they can manage that data warehouse, new data warehouse. So if that data warehouse is having SQL database, it will be considered as a ideal data warehouse. So when we start with the on-premises ADW, on-premises in the sense like a physical location will be there. Here all our CPU, RAM, servers, everything will be kept in one particular place. This we will call it as a on-premises. EDW in the sense enterprise data warehouse. So on-premises EDW cannot accommodate all types of data, like it cannot process semi-structured data and structured data. Only structured data it has been processed. And all users, this elasticity cannot be maintained in the on-premises EDW evolution. And fast answers, yes, it has provided the fast answers with the usage of SQL database. So these two criteria has been succeeded. And again we are moving like because of the challenges whatever seeing all types of data and users, it has been now like again advance came into as first generation cloud. So this is not on premises EDW, like on premises, it is in the cloud. So here also, like all types of data, all types of users cannot be accommodated. It hasn't been succeeded with the last evolution, but fast answers with the SQL database still there is the same traditional flow is following. Again, after this first generation cloud, data lake Hadoop came into the picture. So this Hadoop, again, all types of data, structured, semi structured and unstructured files, has is able to process without any third party tools. And all users, up to some extent, it has been succeeded, serving the multiple users when there is a requirement. And if there is no requirement, it has decreased their compute resources. But it has been failed in the providing the data very fast answers. It has took lot of time, keep on buffering and getting the information. And also one more major thing is, in this Hadoop and data lake, we do have a bits and parts of SQL database, but mostly new technologies to design complete data warehouse. We do require new technologies for this SQL database. So that's the reason there is no much scope, to consider it as a ideal. And next come, now the era is with the cloud data platform. So in this cloud data platform, we do have many flavors, like Azure also there, AWS, everything is there. But Snowflake, which is again hosted in Azure, Snowflake again hosted in AWS GCP, so it can be. So in this Snowflake, we can process all types of data. We can access structured, semi-structured, unstructured data, and convert these types of information to structured data also. So this is all types of data and all users. So as it is a cloud data warehouse, we do have such a provision to make elasticity on the compute resources. When there is a huge demand for you, it just increase automatically. And if it is no demand, like less number of users are serving, I need to reduce my compute resources, automatically it can be done. So the elasticity is unlimited and we can perform any actions without any interruption. And again, here also it has been used SQL database only, not any other technology to design data warehouse. So normal SQL, whoever knew the SQL, they can manage the Snowflake, no issue, no need to learn new technologies, nothing like that. And as it is a cloud data warehouse, and the data replication can be done in other clouds also, other regions also. So what does this other clouds and other regions? Suppose we are in India region, and following the Azure cloud. Now what happened, someone who is sitting in a Europe and they want to retrieve the data, so if they hit the query, they'll get the answer very fastly. But the thing is, what we are doing, like to avoid that less gap also, we are doing data replication. So replication in the sense, whatever the data available, databases available in our account, we are replicating to the other region, other cloud also, so that they can retrieve the data. So whoever sitting in Europe, they can retrieve the data from the Europe region itself. The same data syncing will happen, there is no issue. So this type of privileges we do have. So that's the reason we will get the fast answers for any type of retrieval of the data. So this is the evolution of cloud data platform, like overall. So now we'll discuss the topics which about data warehouse. And not completely about the data warehouse, like whatever the topics related for DDL, DML, DQL, DCL commands, that we will just discuss. So first of all, just ignore data warehouse or something, what about the data, whatever we are discussing, just ignore. So in our real time world also, we have come across warehouses, like seed warehouse are there. Just if we consider like Flipkart or Amazon warehouses, so what does this warehouses will be there? So in this warehouse, respective to that organization, every product information or every item information will be kept in one particular place, so that the distribution can happen very fastly. So if we just consider Flipkart, it is selling all the products like books, stationery, home, kitchen appliances, mobiles, laptops, everything it is selling. So they'll select some parts of country like Bangalore, Hyderabad, Chennai, like major cities, and they'll set up a warehouse. So in this warehouse, what they'll do, they'll maintain all the products information. Products and information in the sense all the products will be available in this warehouse, so that whoever ordering like some mobile from a Bangalore person, so they'll get the distribution delivery very fastly. So whoever around surroundings to the Bangalore, if they are ordering some TV, if the product is available in a warehouse, they'll get the product very easily within a short time. Suppose if we are not maintaining, this TV is holding with the manufacturer. Suppose LG will consider. So LG manufacturer is available in somewhere in Mumbai or Pune. If we want to get the data, if we are not maintaining warehouse, then we need to get the product from Mumbai to Bangalore, which takes time, like 1 day, 2 days, or 3 days, like that. So which means time delay happening means we'll consider, okay, there is a time delay, I'll go to the other e-commerce website, or directly go to the store and purchase, because it's needed urgently for me. So for maintaining, for distribution of the data, we will maintain the warehouses, so that we can easily share our data. So this is like normally whatever we are discussing, real time warehouses. But here in any data warehouse technology, sorry, in any technology, again we'll just talk about this Flipkart only. So Flipkart, whatever their sell, I mean, if someone is ordering, and that order needs to be delivered to the right person at the right time. So all this information, so if we just track our order in a Flipkart, it will say like a product has been dispatched in already delivered to the delivery partner, like in this place, in this place, in this place. This type of information we are seeing in our Flipkart application. So how it is maintained? So again, here like a data warehouse is maintained, in that every information, suppose the product, the once you receive the order, a record will be generated. Okay, this customer has raised an order to get a mobile of some X company. Then once the order is requested, the purchase, the order confirmation will be there. So that particular order confirmation also will be entered as a new record. Then once the dispatch is happened, then again the status will be changed to like, okay, the product has been dispatched. And in transit, then in transit delayed, if any delay is happened, again saying like in transit delayed. Then after that, if it is delivered, then okay, the status will be delivered. So all these types of information will be maintained in the form of tables. So tables again in turn will be available in our databases. So databases again in turn available in our data warehouse. So data warehouse is nothing but group of data specific to an organization. All types of information will be available in our data warehouses for a specific organization. And these data also like relational, suppose we are maintaining 100 tables, so all these 100 tables are also having relation between each other. So any kind of relation, suppose if I am talking like orders and location, so in orders, location ID column will be there. In location, location ID, country, city, address, this type of information will be there. So there is a relation between orders and location table with the location ID. So we can derive for a particular customer from where he is ordering, he or she is ordering. So if I want to get to know, I want to join these two tables and get the information. And as we are saying, data warehouse means it's storing historical information for analytical purpose. So Snowflake is also like a specifically, it's a analytical data warehouse. It will maintain the historical information in our data warehouses. So what happens with the historical information? So if I have the historical information, I can do the forecasting in the sense, like, okay, last year summer, this much cotton bed sheets has been sold out, and previous last year this much, previous to previous this much. Maybe I can forecast, okay, previous to previous year to previous year there is a increase of 2 percentage in the demand. Then again, previous year to last year, there is an increase in the 4%. Now I can expect 2 to 4%, it's a doubling. So maybe now it may be 7 to 8%, it will vary. So this type of analysis, forecasting, decision making will be taken only with the previous years of information. So that's the reason this historical information will be maintained in data warehouses. So if we just consider a simple diagram which represents a data warehouse, like, end goal is all the data, all types of data should be maintained in a data warehouse. So I'm getting the data from data source A, source B, source C, through any ETL, because the Snowflake doesn't connect to any ETL, I mean any other database or other third party tool, and get the information. So we need to use must and should any ETL streaming only. So all these types of data can be accommodated in data warehouses, because we have Snowflake is again can accept all types of data. So that's the reason I can get the data in any form. So this is like, if we just consider one more picture. So end goal is like maintaining a modern data warehouse. In this modern data warehouse, it can accept the data which is coming from websites or mobiles, like through API information. Whatever you fill in the application forms, that data also it can accept. Telephone and call center, so any call center logging information is there. So this person has raised a request, so we have attended this request, resolution has been provided, or some time asked for to wait on some time. So this type of information also it will maintain in a modern data warehouse. And staff rotas, so for any organization, any type of organization, we do require employees. So for each employee, if there is a sister, I mean, rotational shifts are there, normal, not regular shifts, then we have to maintain the staff rotas. So that type of information may be maintained in an Excel sheet, or somewhere on a board, or in a form of image. So that type of information also can accept by a modern data warehouse. And staff performance, so every organization, like, it has to appreciate the employee. So for that reason there will be a benchmark called performance. So this staff performance, which is like in the form of charts or pie charts, it also can accept the modern data warehouse. And finance and accounting, so if there is an organization means, like, however employees will be there, so in the similar way we should have a funding, finance should be there. So should the to maintain that finance, we need to have a accounting department. So this data information related to the finance, accounting also can accept, also needs to accept by a warehouse. And warehouse logistics, so if it's a manufacturing company, then they will directly deliver the products. So for that they need to maintain some logistics, transportation information. So that information also can be maintained in a modern data warehouse. Production, so end goal is like whatever we are producing. Suppose if we are manufacturing some medicines, so that production information will be maintained in ERPs. So ERPs is nothing but like traditional databases. So that type of information also will accept modern data warehouses. And CRM data, so CRM data is also again like I mean, information holding about the customers. Again, it may be in a data format or a graphs format, whatever it may be, it should accept the modern data warehouses. So nothing but like a data warehouse should accept all types of data coming from any type of source, it should accept. Okay, data warehouse accepted and maintained in a data warehouse. So who will be using this data, what for what purpose they'll be maintaining the data? So again, to provide some dashboards, like to generate dashboards based on this employee had, if we just consider staff rotas and staff performance is in a different phase. Suppose if I want to just see like one employee who has been worked in most of the night shifts and what is their performance, then all the information, staff rotas information individual, staff performance individual is an individual, but I am getting all those different informations into my data warehouse. So with the help of keeping in one particular place, so that I can just easily join the tables and provide the dashboard, the figures to dashboard team. So based on that data, they'll generate the reports, either pie charts, bar charts, line graphs, and anything they can generate. And for doing analytics also, if complete information is available in our data warehouse, we can just easily analyze the data, do some forecasting, decision making, everything can happen with the data warehouse information. So this is like just a modern information. And until now we are discussing about a data warehouse. So in this data warehouse, like what exactly will be available, we understood some data will be available, but that data also doesn't like there is a hierarchy. So that hierarchy starts with the database. In data warehouses, databases will be there. So in this database, like it's for a namesake only, one object, and in that object we do have schemas. So again in schemas we do have tables. So in a database, data will be stored in the form of rows and columns. So rows and columns is nothing but a table. So currently in market we do have many databases: MySQL, NoSQL, Oracle, MongoDB, SQL Server, etc., etc. Like we do have many databases in the market. And what is we are just considering data warehouse, database. So what does data means? So a small unit of information. So it may be having like very various kinds of formats. Suppose if I ask anyone like what is your name, then I can just say like my name is Lahari, which is in a characters letters format. So that it will treat at, in a database it will treat it as a text data type or string data type, varchar data type. Suppose if I ask like what is your roll number, so roll number it may be 1 2 3 4 5 6. So our data is in the form of numbers, integers. Suppose if I ask like what is the cost of this particular pen or this particular product, you will say like this is 23.35 uh, paise, like that. So that is again in the form of decimals, float. So we cannot just say a data is in a fixed format. It may be in the form of text, it may be in the form of number, it may be in the form of date also. If I ask like what is your date of birth, so you'll say some 1999 hyphen February hyphen 12th or 13th, you will say. So this is again in the form of date data type. So what is the size of your computer is holding, how much RAM it is holding. So you'll say like 1k bytes or 1 GB bytes. So in this form you will say, you'll express your information. So in data warehouse also, we will have multiple data types which says okay, my column will be holding this type of information. It may have text information, it may have number information, it may have date information, like that it will mention. So this is data. And coming to database objects, so I'm not expressing like generically what are the database objects related to the Snowflake. I will call it like, if I am calling object or database object, anything in this like list it may be. So it may be a warehouse, so we'll call a warehouse also as object. Database, schema, table, view, stored proc, UDF, stages, task, stream. So in other data warehouses or other databases, we do have many other database objects also, but only for Snowflake these type of objects will be available. Okay. Now, just coming to the SQL introduction, basic introduction, it stands for a structured query language. Suppose if we are seeing like a Flipkart app, just again I'll go to the same example. We will install the app and we'll use the app. So for designing that app, there are some front end technologies and back end technologies like Java, Angular Java, .NET. Like this type of technologies are there to design your application. So here also, to design your data warehouse, we do require one language, which is nothing but SQL, or people will call it as a SQL. So this SQL stands for Structured Query Language. So this language is used to design your database, and it was invented in early 1970s only by Raymond Boyce and Donald Chamberlain at the San Jose Research Laboratory of IBM Corporation. From there onwards, this SQL is still working. This language, like which is used to design your data warehouse, it is still, we are still using this particular SQL. And majorly, like what type of things I need to learn in SQL. So these four categories. First, to design your data warehouse, we do require DDL commands. So DDL in the sense data definition language, to define your object, like whatever it may be, warehouse, database, schema, table, to define your object, to create your object, or to change the properties of your object, to remove the object, we will use the DDL commands. DML commands, data manipulation language. So once the object is created, we will keep some data, we will update the data, we will remove the data. So here the data, not the object. So for doing such activities, we will go for the DML commands. DQL, so to retrieve the data, whatever we have introduced or inserted the data into the tables, if we want to retrieve the data, then we will use the data query language. And DCL, so for any kind of object whatever you are creating, some control mechanism is there, like who will be accessing this data or who will not be accessing the this data. So you want to provide some restrictions, limitations on the objects. So for that, we will use the data control language commands. So this is about just introduction. And here just we'll start with the DDL commands. So DDL stands for data definition language. So in these, this particular DDL commands will be used to create any object, to modify any object, or to remove the object from the warehouse. So here I am saying to create the object, to modify the object, to remove the object from the warehouse. So here I am saying object. So object, it may be a warehouse, it may be a database, schema, table. For any type of object creation, you do require DDL commands. So here comes to the DDL commands create. So whenever, like in the, for the initial time, for the first time you are creating, then we'll call it as a create. Or if you want to remove completely from your warehouse, then we'll use the drop command. If you want to change the properties of your object, so object name or object properties, if you want to change, like without dropping the object, you can just use the alter command and change the properties. Truncate, so completely removing the data from the object. So that is called truncate command. And coming to the DDL commands, while defining like your table or any object, you do require data types. Okay, my table is holding this type of information, it is having a name information, so I can go for a varchar. If it is having a roll number, I can go for a number character data type. If it is having some date information like date of birth, date of joining, so I'll go for the data. And if I am having, my data is having exact timestamp value, like YYY, hours, minutes, seconds, nanoseconds, this information is there, I'll go with the timestamp. So we'll see each and, I mean, currently while discussing the DDL commands, maybe we will not see in depth about the data types, but in our project, when we enter into the training, we will see, come across all the data types, whatever we are seeing. So now we'll just start the practical. Okay, so first we'll see about the create statement. So as we already knew, like who have taken Snowflake trial account, so it will be the home page will be like this. And once you enter into the home page, like I want to create a worksheet or open a worksheet. So if you do have already existing, then you just directly click on that. Or if you want to click a new worksheet, if you want to have a fresh worksheet, just click on the plus button of the worksheet, and it will be opening the fresh worksheet in your in your left pane, you can see. But and you can write your queries, whatever the queries you want, you can write here, and click on the run button to execute those queries. So currently I do have already a query sheet, so that I'm just using the same query sheet. And here nothing, like if you just see whatever the query I can write here, I can write and click on the run button, so that automatically that query will be running. Now we'll start with the creation of the database, because if I need to hold a table, I need to create a table, must and should I do require a schema. And if I need to create a schema, must and should I need to have a database. So for that reason, we will create a database first. So currently, to see like whatever the existing databases are available, just click on the databases page. And if you see here, you will have two databases. If I just want to refresh, click on the three dots and refresh it. So for every person who has taken trial version, all those people might have received these two, not might, mandatorily these two databases will be coming. So these are the two default databases which is imported from Snowflake itself directly, just to understand how the data flow will be there, how the objects will be there. Just to understand, these two databases will be there from the Snowflake itself. And currently we will create a new database, and under that what will be there, we'll see. So if I just expand the databases, I mean just see existing databases how it will be. So if I just expand here, I will have a schemas. So under a database, schema will be there. So under schema, you'll have the list of the objects. So here we have views, functions, like we do have. So in other things, like we may have in other schemas, we may have only functions. In other schemas, we may have tables. Like it may be, it depends again, like schema to schema. So just to understand the hierarchy, first a database will be there. Under that, schemas will be there. So under schemas, you will create the rest of the objects. It may be a table, it may be a view, it may be a stored procedure, function, stage, pipe, task, stream. Anything needs to be created under a schema. So now we'll start creating a database. So this is the syntax purely, and if we understand one particular statement syntax, we can create the other database, other objects also easily. So as it is a creation of the object, I'm using the keyword called create. And what type of object you are going to create. So if it is a database, you need to mention it as a database. If it is a schema, you have to mention it as a schema. If it is a table, you have to mention as a table. Stage, Snowpipe, like whatever it may be, like you have to mention the next word as object type and the name of the object. So here it is your choice. Whatever, if you want to, I mean, name it the database, that name you can go for it. Like ideal, according to the naming conventions, like in real time projects also, people will follow some standards. Suppose if we are creating database, at the prefix or at the suffix, they will add db or d. D is nothing but database. If it is a table, we will call prefix or suffix it with tb or tbl, t underscore, like that we will suffix it. So here also I am just giving a prefix d underscore sql, as it is a SQL class, just creating a database related to d underscore sql. So if I run this command, and once your query is completed, we have to enclose with I mean stop your query, complete your query with semicolon. If you are not complete, I mean ending with semicolon, then it will be treated as a query is not completed yet, still some queries need to be written or something is there, it will treat it as. To complete your query, to understand for Snowflake or a compiler, it should be ended with semicolon. Now what I will do, I will execute this statement, create database, database name. So if I run this, I will get the message, whether it is a success message or failure message. Here in the down page, you will get. So here if you see status database d underscore sql successfully created. So here we are seeing, but in the pane also, like in the picture representation also, we have to see, right? If you just click on the refresh, you will get the d underscore sql database. So if I just expand this database, we do have two schemas. So again, like I haven't created any schemas, just we have created a database. Even though these two schemas came into the picture, information schema, public schema. So these are the default schemas for every database. Whatever the database you create, these data schemas will be coming into the in your database defaultly from Snowflake itself. So we cannot remove or we cannot change it. So here this information schema will be holding the information about each object which is available in your database. So this is completely maintained by Snowflake. Nothing here. We can just use this information schema object, but we cannot update, delete, insert, drop, nothing we can do. And public schema, so this is the place, like just Snowflake has given, like if you want to create an object, table, view, stage, you can use this public schema and create it. So if it is not, like if you don't want to use the public schema, if you want to create a customized schema with your own naming, then you can create it, no problem. So but these two will be defaultly coming to the in a database. So here we are seeing, but through query, if I want to understand how many databases are available in my account, then use the show. So show in the sense, just get the list of object. So again, the object type in the plural form. So here we are asking for to show the information of databases. So that's the reason show databases. If you want to get the information of tables, show tables, show views, show stages, show pipes. So everything show is common, but the next thing is data object type. Whatever your object type is there, it you need to give in a plural form. So then if I run this command, show databases, just click on the run button, you will get the list of the databases, when it got created, what is the name of the database, is default, is current, origin, whatever it may be. So I'm not explaining all this because still it is a just in, I mean, SQL class, not going in depth. We do have, like while talking about the account hierarchy, at that time I'll explain what are these things. Okay, suppose if you want to describe your database, like what in your database, what information is holding, then you can use DESC or DESCRIBE. So describe type of object, like what type of object you are going to describe, and the object name. So here you are describing a database, so that's the reason describe database name. If you are describing a table, describe table name. So that information, the syntax will be very similar. Okay, if I describe under my database, what will be there, schemas will be there. So that's the reason it is appearing this when the schemas has been created, and what is the name of the schema, and what kind. If it is a schema, then it's schema. If it is any other thing, then it will be listing here in a database. So this is just a database creation. Now under this database, we will create a schema. So first of all, I will start creating a schema. So create keyword, and what type of object you are going to create, it's a schema. So schema, and name of the schema. So I am just mentioning it as a learning. Still we are SQL learners, right? So that's the reason I'm creating a schema with the name of learning. You can create with any name as of your choice. There is no problem. And now if I am running this query, just selecting the query, and the schema learning successfully created. So I want to see both in UI and also through command, right? So first through UI we will see, just click on the refresh, and you got the learning schema. If I just expand this learning schema, currently I don't have no objects find, I don't have anything, still just a brand new schema we have created. So if you want to get the list of schemas, then what you can do, show schemas. Okay, so if you just, I mean, other method is, currently earlier, like I have just selected the complete query and clicked on run button. Okay, so I got the data. The other method is if you are enclosing your semicolon with after the completion of query, just keep your cursor anywhere before this semicolon. Then you can click on the run button. Then it will treat it as a single query and get the information. So here in your schemas, like in your database, schemas are information schema, learning schema, public schema, and the rest of the properties about the schema are available in your database. And now if you want to describe your schema, suppose if you want to describe information schema, then what you have to write, desc or describe schema and schema name, whatever the schema name. Suppose if you want to describe information schema, then you can click on this. Just keep the your cursor, because I have ended with semicolon, and click on the run button. So you'll get whatever the objects available in your information schema. Suppose if you want to describe your learning schema, whatever just now created, so we'll just say describe schema learning. And if I run this query, then I don't have anything because we haven't created anything, just it's a brand new schema. Okay, so this is about database and
Lahari, I
schema.
think its screen is frozen.
No, nothing like that, it's fine for me. What, which screen you are able to see?
Yeah, because I can see that pop-up with the thumbnail on the learning schema. That's it. Yeah, now I can see it.
Us. Still we are discussing the same. Okay, so up to now, like the database and schema creation, any doubts for anyone?
Hey there, this is Shad. Can you hear me?
Yes, yes, I am able to.
Okay, so as you said that we can do the creation part through the query, right? Is any way like in the SQL we have option like right click and create a database? Do we have anything from the UI, or it's something that we
uh,
have to do through the query?
yes, yes, we have through UI also.
Okay,
Yeah, as this is just SQL class, right? So I just want to explain about the commands. So that's
okay,
the reason, like just working on commands only.
good, got it.
Okay, I hope no one are having doubts. Okay, now we'll jump, just switch back to like a creation of a table. How can we create a table? So here, for database and for schema, there won't be much properties, like because they are just I mean, they are just hierarchy objects. Like they will not store any data. But coming to a table in the sense like it will have rows and the data in the form of rows and columns. So we have to define what is our column name. So column name in the sense what is, it's a vertical values. So this is like, suppose if we want to consider a trainee details, whatever we are attending, what is the trainee ID of the person, trainee name of the person, current skills whatever they are holding. So these all are the column names. Under the column names you will give the information in the form of rows. If you just consider, I mean, I can open an Excel and we can just see this. So I can show you the data so that we can understand like how table looks like. Okay, already this sheet open, we'll use the Schema. So if we just consider, this is like if I want to collect the information of all your trainee people, then I can say trainee ID, this is my column name, and trainee name, this is the column name which holds the name information, and skill, currently what type of skill does the trainee person is holding. So this, like whatever these vertical values are called as a columns. So under these columns, you'll provide the data records. We'll call it as a row, record, data, whatever it may be. So you'll say for the trainee ID is 1 and their name is George and they are currently holding the Snowflake skill. Again, the trainee ID is 2 and their name is Mary and they are holding the skill of talent. So in this way, you'll give the information in the form of rows and columns, so which is nothing but it whatever like we are holding this information, we will call it as a table. So to create a table, just like create table, table name will not work. You want to say in my table these columns will be available, and for these columns this type of data, number data or characters data, date format data, so whatever your column is holding, then you have to define that information also while creating a table. So here just syntax, if we see create table, so we are creating a table and the table name, so whatever it may be table name, that table name you are giving. So here I'm saying TBL, just a representation naming convention, TBL underscore trainee underscore details. So I'm just holding in this table the trainee details information, like bracket open. So this is purely syntax. You want to represent your columns information with a bracket, in a brackets only, bracket open and bracket close. In between you have to provide your list of columns. So again, I do have a column name called trainee ID, but in this trainee ID, I will store the information related to integer data type. So integer data type in the sense 1, 2, 3, 4, 5, 6, even 20.24, not decimals also, only integer data type, integer values I will hold. So that is the reason I'm just taking integer. And trainee name, so this is my second column and holding the information related to the characters. So the name may be consists of characters and numbers also. So whatever it may be, like I have used the varchar. And skill, so skill also again having characters. So that's the reason I am using varchar 255. So my skill will not exceed the character length of 255. If I'm not giving anything, it will take the default value, whatever the maximum value holding for a varchar data type, that value it will be taken. Here now it's varchar 255. If I'm mentioning, it will, this skill column will hold only 255 characters. If you are getting 256 characters, it will not allow you to enter into the table. So once all your, I mean, again column to column, so after explaining about your column name and the data type, you have to separate it with a comma, so that Snowflake will understand, compiler will understand, okay, this column has been completed, so I have encountered a comma, so that the second column has been started. And after the second column completion, if you provide comma, it will treat, okay, this is my second column and again my third column has started. So in this way, you need to provide a separator of comma for each column. So once all your columns are completed, as there is no fourth column, I'm not giving comma as my separator, so it's completed. And then bracket close, semicolon. So semicolon just says like my query is completed. I can, if I keep my cursor anywhere, then I can run the query. So if I'm keeping the cursor somewhere and just clicking on a run button, okay, my table trainee details successfully created. So we'll just see in both the things through UI. How can we see? Just click on the refresh and I got a folder called tables. So if I just expand the folder, I got the table trainee details. So if you just hover your mouse button on the table name, you will get the pop up in a white screen. So here you will see details about this table, number of rows, like what is the data count available in your table. So currently we just created a brand new table, so there won't be any data, zero records. And size of the table, so if there is the data, then size will be calculated. Currently we don't have data, so size is not there. Cluster key, so clustering is the concept like which is used to sort the data in your table. So currently we haven't given anything, so it's a blank. And owner, who has created, with which role has been created this particular table. So I have logged in with account admin, So that's the reason account admin will be my owner. And created, just now we created, after few minutes it will just appear the time, what is the exact time. And comments, so while creating a table, have you given any comments here? If it is available, then it will show. And definition, so definition in the sense, at the time of table creation, whatever you have used here, it will appear the definition. So you can, if you want the definition of a table or any object, you can just come here and hover your mouse button, click on the definition, just copy. Here you have an option called copy, just click on the copy, it will copy the definition. Or through queries, if you want to see, so if you want to get the list of the tables, just again show tables. So it's a plural form of the table, and you'll get the list of the tables, whatever you have in your database and schema. So when it got created, what is the name of the table, which database it is holding, which schema it is holding, what kind, rest of the information about a table. And if you want to describe your table, so if you are describing table means, whatever the columns are there, whatever the constraints are there, about the those columns information it will show. So here DESC, describe table, table name. So if you are running this query, just click on the run button, you will get the list of the columns, whatever you are seeing, trainee id, trainee name, skill, in the order whatever we have provided at the time of creation. And here it's a number 38 comma 0, but we have given it as a integer. But why it is treated as number in Snowflake, like if you are using integer or decimal, it will be taken as a number only, not integer. So but here if you see the precision comma scale, like 38 is my precision, scale is 0. So nothing, but it will not allow the decimal values. Suppose if your precision is 38 comma 1, that it will allow the decimal values of 1 after decimal point. The right side value will be holding one information, like 23.1, 47.2, like this it will hold. So even if you give integer also, it will treat it as a number 38 comma 0. And for trainee name, I have just used varchar without any length. So that's the reason the maximum length has been taken. So the maximum length of a varchar column hold means this much, like around 16 lakhs or 16 million. So that much information a column can hold if you are not giving any length. So suppose skill, so here skill varchar 255. That means it will hold only the 255 characters, not more than that. And here like the properties of the column. So whether it's a column or constraints, null constraint is there. Have you given any default value, primary key, unique key, check constraint, expression, policy names have you given? So any type of, I mean, about the columns information, you will see here in the describe table, table name. Suppose like whatever we have just seen the definition, right? So if you want to get the definition of a table completely, so here you are just getting whole if you are using the describe, you are getting normally in the form of rows and columns. But you want exactly whatever you have created, you can use this get ddl function. So this get ddl function needs to be given two input parameters. So just I'll explain. So select GetDDL is a built-in function, system defined function. So for this function, you need to pass two input arguments. So first input argument is what type of object you are going to get the definition. So if you are getting the definition of a database, just give a database and the name of the database. If you are going to get the definition of a schema, then schema name and schema and the name of the schema. So currently it's a table and table name. So just click on this, then you will get the definition. So if you see here, just I'm copying from here, click to copy, and if I'm running this, I have create or replace table, table name, and whatever the columns list what we have given, trainee ID number 38 comma 0, because integer also will be categorized under number, and trainee name with the maximum length of the varchar, and skill whatever we have provided varchar 255. So if you want to get the definition in this format also, you may get two methods are there. So this is about DDL command. Okay, we'll just go with the alter also. I'll explain the alter. So currently, like with the name itself, we can understand alter in the sense the existing object properties. If you want to change, then you can change the properties without removing. So currently what we are doing, like if the object is already available and if you want to change the properties, we can do two methods. One is removing that object and recreating a new one with the new properties, or the second method is just don't drop the object, don't remove the object. I can just use my alter statement, alter command, and I can just change the properties with the alter statement. So we'll see how suppose I want to change my table name. Currently the name is table trainee details, but I want to change this table trainee details as some new name. So then what I will do, I will just use my alter statement. So alter statement syntax is alter, and what type of object you are going to alter, that object name. So here it is a table, so alter table, and the table name, virginal table name, whatever it is there, that virginal table name. And after that, rename to, what you are doing, you are renaming the object name to new object name. So rename to the new object name. So the new object name is table trainee details renamed. So it's similar syntax, alter table, virginal object, rename to new object name. So can we do only renaming with the alter statement? Not like that. So for understanding purpose, what is the alter statement? I have just used a rename. So any type of property, if you want to add the column, if you want to drop the column, if you want to change the data type of the column, if you want to set the retention time, if you want to add the constraints, anything can be done on the existing object through alter statement. So we'll see currently like with the rename how it works. So alter table, table name, rename to new table name. So statement executed successfully. If I just refresh here, my table name has been renamed without dropping. So still it is showing when it got created 8 minutes ago only. It hasn't like taken the current time. It has been created, but just we have used the alter statement. So the same thing, if you want to have the show tables, then you can get the show tables list, the table trainee details rename. And if you want to get the describe table, you can do it, describe table. Okay, in the similar way, if you want to change your schema, then what you will do, alter schema, original object name, rename to new object name. So if I run this command, my schema name currently it is learning, now it will change to learning underscore rename. So statement executed successfully. Then if I refresh here, okay, my schema has been changed to learning underscore rename. And if I want to change my database, rename database, then I can use the alter database, the original object database name, rename to new name. So I can run this command. Okay, statement executed successfully, and if I just refresh it, my name of the database will be changed. So to change any kind of property, not only rename, we will use the alter statement. So this is about alter statement. Any doubts up to here?
No, ma'am.
Okay, thanks for confirming.
Yeah, I mean, like whatever the commands we have used, apart
Mhm.
from that, like through UI, can you do that? Like, is there an option like that?
Yes,
I mean, like,
because we can do, as I mentioned, like this is SQL class, right? We need to get in
yeah,
touch with the commands. So I'm showing while doing I mean when we switch to Snowflake, I'll show you both how to do through commands and also through UI how can we create.
okay, thank you.
Okay,
Hey, Lakshmi, this is Sharath.
yes, Sharat.
Hey, just one thing I want to understand, not regarding the queries that you're saying. The only thing I was little understanding is we can have a multiple tables, like you have the three databases all over your left side, right? The SQL
Mm,
and the Snowflake and the Snowflake, right? This
mm.
same table name can be reside in all the three of them, like
Yes.
same, yes, right? So how you get to know that you're actually on the T-SQL
Mm.
rename database query?
Mm, mm, mm.
So I didn't
Yeah.
understand because when you're actually altering the table, right? How you're making
Mhm.
sure that you're altering the table in the D SQL rather than the Snowflake?
Understood, understood. See, anywhere I haven't, like, if we just consider database name, there won't be any hierarchy. But if you just consider table trainee details, I have just used the name, table name, but I am not saying in which database or in which schema need to be created, because here we do have a context function. So here you can set like which database and which schema you need to create. So as I have created database and schema, then defaultly automatically it's set to the database dot schema name as context. So whenever you want to create a table, two methods, I mean again two methods you can follow. You can set your context. So suppose I want to create a table under DSQL rename, in which schema you want to create. So if I want to create in a public schema, I can just use the public schema and click, then you can create a table. So it now, with this option, there is no need to give your qualified name, fully qualified name. Just if you directly create, it will just consider, okay, this table needs to be created under a public schema in a database called d underscore sql rename. Suppose if you are not using the context, or if you want to create in some other database, like irrespective of your context, then you have to use your fully qualified name. So fully qualified name in the sense your database name. So your database name is d underscore sql
Got it.
getting. So learning rename dot your table name. So your fully qualified object name comprises every time table name. If it is a table, if we are saying if it is a pipe, then pipe name, and it should be under a schema. So schema name. It should be under a database. So the database name. So now I am in a context of d underscore sql rename public schema, but I want to create a table in learning renamed schema. Then I can do now. Okay, my table trainee
Yeah,
details created successfully. If I just go and see, so under the tables, I just refresh it. Yeah, my table has been created in this schema. So in this way, we can just change our context.
yeah, makes sense. Thanks.
Okay, no problem.
And one more thing, as you said, that warehouse, right? Under the warehouse, we have the multiple databases, but here it says that no warehouse selected, so it doesn't matter whether there is a
Uh,
warehouse or not.
yeah, this warehouse is different, and whatever we have discussed, the data warehouse is different. So here in Snowflake we do have like a, to provide the compute resources, to assign the compute resources for a query, object needs to be created, virtual warehouse. So still for DDL commands, just it's a creation of the object, right? So for that reason we don't require a warehouse. Only for DML commands, insert, delete, update, for that commands we do require warehouse. So tomorrow I'll explain at the time of DML commands.
Gotcha.
Okay, any others have doubts? Okay, if no, like we'll just wind up our call and meet in tomorrow's class. Thanks guys, thanks for your time.